So I want to start today just by asking everyone to take a moment to think about the potential consequences of a ship collision with an offshore platform. I believe everyone here today would step in and act if they saw something unsafe, or if an opportunity arose, big or small, to improve safety in any way. I genuinely believe everyone would take action. On the flip side, I think it would be our worst nightmare to deal with the fallout and aftermath of a major incident involving the preventable loss of life. So I'm sure everyone can picture some of the potential consequences of a ship collision with an offshore asset. You might be thinking about a minor collision, or you might be thinking about the other end of the spectrum. But my question to everyone here today is, have we done all we can do? So I'm Paul Carter from Ultra INC, and today I want to talk about managing collision risk offshore, not from a single system or a purely compliance perspective, but from the point of view of how people, systems, and operational reality interact. I want to touch on some of the risks, some of the human factors, and some of the lessons learned, then spend some time on focusing on what good looks like. But briefly, for context, who are we? With more than 25 years of proven success in the field, RUSE and now SAMS helps operators detect, respond to, and prevent offshore collisions before they happen. Our system brings together radar, AIS, CCTV, ADS-B, and more into one clean, uncluttered interface. Operators get the full picture at a glance, with audio and visual alerts tied to user-defined response plans. It's all logged for post-event analysis and continued improvement. My team specifically provides 24/7 support to customers to minimize system downtime and make sure the system continues to provide value long after it has been delivered. So, offshore operations are complex by design. You've got multiple hazards, changing environment conditions, and people balancing competing priorities. Risk doesn't usually come from one big failure. It comes from small things interacting in ways we didn't expect. For example, in 2005, there was an incident that resulted in 22 fatalities and around $370 million in damage. Does anyone know the initial cause of that started all the dominoes falling? It was a chef that cut his hand on a multi-purpose support vessel. From there, the dominoes started to fall. The weather and sea state prevented medevac via helicopter to the vessel, so it was decided that they would transfer the injured person by man-ride and basket to the platform. However, the leeward crane was unavailable, and then there was a faulty dynamic positioning system that added another layer. It's a terrible example, but a very clear example of how risk can build through a series of separate issues, each one manageable on its own, but far more serious when they combine. So going back to my initial question, the potential of a consequence of a ship collision with an offshore platform. Let's think about a slow-speed collision involving a small vessel. What implications could that have? It may not cause major structural damage to the platform, but it will likely stop operations. What about for the small vessel? The consequences could be far more serious. It could receive major damage, it could sink. At that point, we may be dealing with injuries or worse, and we're now into rescue and recovery. Then there's the question of what happens to the vessel. Does it need to be recovered? Does it need to be located? Does it damage subsea infrastructure? Who has to deal with all of this? What are the implications to the operator? So we've already touched on the Mumbai High, which was a collision involving a 100-meter vessel, which resulted in the complete loss of both platform and vessel. Closer to home, think about last year, with a collision between the MV Solong and the Stena Immaculate. What could the outcome look like with a similar collision with an offshore asset? Again, May last year, there was a Peruvian naval vessel that collided with an oil platform, resulting in multiple fatalities. Despite the controls we have in place, vessel collision with offshore infrastructure remains a major accident hazard. When we look at collision events, human factors are almost always present, not because people don't care, but because people are operating under pressure. Distractions, workload, task switching, and gradual normalization all play a part. Loss of situational awareness tends to happen gradually and quietly. But are we doing enough away from the front line? Are systems being maintained properly? Are alarm criteria and the implications of those alarms being reviewed regularly? Are environmental factors affecting system performance? And is operator interaction and performance being monitored, reviewed, and audited? And finally, are operators of collision avoidance systems being given regular, relevant training? Last year, the Health and Safety Executive issued Safety Bulletin ED01-2025. It highlights a rise in vessel collisions and near misses with offshore structures. A recurring theme is watchkeeping failure, often linked to distraction by too much non-navigational tasks. This isn't about incompetency, it's about systems and crews being asked to do too much without enough support at the right time. To me, it's worrying to see the rise in incidents, and it really should focus all of us who are involved with mitigating these risks. So I come back to my original question, have we done all we can do? We must, as an industry, keep looking for improvement. We must learn from incidents, take opportunities to improve, and keep the worst case scenario in our mind to maintain our focus. Across incidents, investigations, and assurance activities, we keep seeing patterns repeat. Systems appear operational, but intermittent faults, degraded performance, and environmental impacts are not always treated as safety significant. That matters because those conditions can build confusion, uncertainty, and in some cases, alarm floods. The Milford Haven refinery incident remains a powerful example. In the 11 minutes before the explosion, operators were faced with around 275 alarms. The problem was not just volume, it was poor prioritization and displays that did not help people understand what mattered most. Another repeat lesson is that checks can pass on paper, while the real operating picture is far less certain. Changes are sometimes introduced before there is full confidence in the baseline, and training can prove attendance without proving understanding under pressure. Add weak communication or misinterpretation of system data, and the result is not always immediate failure, it is delayed recognition. And once recognition is delayed, the time available to respond starts to disappear. The lesson is not about blame, it's about recognizing how easily risk can build before someone fully understands what they are seeing. So detection is only valuable if it creates usable time and the operator is able to act within it. Detection on its own does not equal understanding. Systems may detect early deviation, but that does not always mean the significance is recognized. Warnings can be ignored, misread, or normalized, especially when operators are under pressure, managing multiple demands or trying to make sense of weak or conflicting information. We often assume there's enough time to recognize the issue, diagnose it, make a decision, and take action. But in reality, stress, uncertainty, workload, and poor communication consumes that time very quickly. A few small delays, late detection, hesitation, slow escalation can combine to quietly remove the safety margin. And by the time the risk is fully understood, the range of safe options may have already narrowed. And that's the difference between a near miss and a major incident. It's often measured in whether we had a warning, but whether the warning was translated into action in time. So when we talk about safety-critical systems offshore, one of the biggest risks is assuming that because something looks right on paper, it will perform when it really matters. A system, a process, or even a person can appear fully compliant. Inspections have been passed, maintenance has been completed, procedures are in place, and training has been signed off. And on the surface, that gives reassurance. But the real test does not happen in ideal conditions. It happens under pressure, when workloads increase, when weather deteriorates, when distraction builds, and when equipment is degraded, and when alarms start coming in faster than it can be processed. That is where we see what I would call the assurance gap, the gap between paper assurance and real operational performance. And this matters because a lot of our checks are still done in controlled conditions. Audits often measure documentation more than behaviour. Training may prove attendance, but not necessarily competence under pressure. Maintenance can confirm a system is available, but not that it is resilient. So the danger is this. Everything can look fine right up until reality tests it. Take a collision avoidance system as an example. It may be fully maintained, recently tested, and technically available. But if alarms are poorly prioritized, if operators are overloaded, if training is weak, or if distraction, workload, or if degraded performance becomes normalized, then that same system may still fail to support a safe decision-making at the exact moment it is needed most. And that, for me, is a real issue. Compliance is important, but compliance alone is not the same as confidence. So that's exactly why collision risk has to be treated as a system problem. It does not sit in one piece of equipment, one operator, one procedure. It sits in interaction between people, procedures, training, system performance, communication, supervision, and assurance. If we only focus on one element in isolation, we risk creating reassurance without resilience. A good procedure can still fail if it's hard to apply under pressure. A reliable system can still underperform if alarms are unclear or trust has been lost. A trained operator can struggle if workload, distractions, and competing priorities are not understood. So if we want to reduce collision risk, we have to design and assure the whole operating system, not just individual parts of it, because good performance is not created by one control working on its own. It comes from the whole system supporting the right decisions early enough. And that's what good starts to look like. So, if collision risk is a system problem, then what good looks like is a system not just installed, but actively kept healthy, understood, and supported through its life. Good means weak signals are picked up early, alarms are trusted, degraded performance is noticed before it becomes normal, and operators are supported to make the right call in time. If assurance is based on real use, not just paper, and it means system, the people, and the support model are all working together consistently. That's where the service we provide becomes so important. Weekly health checks help to keep intermittent issues, drift, nuisance alarms, and early signs of degradation before they erode trust in the system. Planned maintenance helps make sure that the system is not only available but reliable when conditions are changing. Operator training builds confidence and familiarity, while operator interaction audits help us understand how the system is really being used when people hesitate, when alarms are misunderstood, and when the workload may be shaping behaviour. System KPIs then give us evidence to see whether performance is holding where it should be and whether improvements are actually working. Our 24/7 on-call support matters because offshore risk does not wait for office hours. When something changes, confidence comes from knowing there's immediate access to people who understand the system and can help diagnose the issue and support the right decision before time is lost. So for me, what good looks like is not a single feature or a single test, it's a whole support model that keeps detection credible, alarms meaningful, operators ready, and the assurance connected to reality. And that naturally leads on to the next few points: how alarms are managed, how people and organizations work together around the system, and the key lessons we should take away. This is where alarm management becomes critical. Standards like IEC 62682 are very clear. Alarms should support decision-making, not compete with it. Their purpose is not simply to notify, it's to help the operator recognize what matters, understand the significance, and act in time. That means alarms need to be meaningful, prioritized, and actionable. If everything alarms, nothing stands out. And if nuisance alarms, repetition, or poor prioritizations becomes normal, trust starts to erode, which makes the next genuinely important alert harder to recognize for what it is. Good alarm management is therefore not just a technical exercise, it's an operational safeguard. It helps protect attention, preserve situational awareness, and surface weak signals before they are lost in the noise. And because that cannot be achieved by one team alone, it depends on the right collaboration, governance, and follow-through around the system. No single role owns collision risk, and no single organization can manage it alone. Operators, ERRV crews, duty holders, and system providers all see different parts of the picture. Real safety comes when those perspectives are connected, when concerns are raised early, when information is shared clearly, and when support does not stop at installation. That means collaboration has to be practical and not just procedural. It's about having the right conversations before a problem becomes an event. It's about feeding back when alarms are unclear, raising concerns when conditions are changing, recognizing weak signals early, and suppliers responding as part of the safety picture rather than just a vendor. It also means creating a learning loop. Reports need to lead to action, actions need to be reviewed, and the lessons need to travel across assets and organizations, not stay isolated in one team. Some operators are doing things very well, others are doing things differently. The opportunity for the wider industry is to learn from both, to raise expectation, improve consistency, and strengthen how these systems are used and supported through the life cycle. Because ultimately, collaboration is not just about shared responsibility after something happens. It's about shaping a better performance before it does. And if we get that right, we give ourselves a much better chance of answering the bigger question honestly: have we done all we can do? So the key messages I'd leave you with are these. Collision risk is systemic, which means it has to be managed across people, technology, procedures, and support, not in isolation. If we treat it only as a marine issue, only a technology issue, or only a compliance issue, we miss the interactions that create the risk in the first place. Human factors are not secondary to the discussion, they're at the center of it. Workload, distraction, trust, communication, and confidence all shape whether a warning becomes an action in time. And as we saw earlier, loss of situational awareness rarely arrives all at once. It builds quietly, often when everything still appears manageable. Early detection only has value if it creates usable time, and the assurance only has value if it reflects real operational conditions rather than ideal ones. The challenge behind the assurance gap: a system can pass on paper and still leave operators exposed when pressure, weather, degraded equipment, or alarm overload change the picture. And that's why good support matters, from health checks and maintenance to training, audits, KPI, and rapid expertise response when conditions change. What good looks like is not just a system that is installed and signed off. It's a system that stays healthy, trusted, understood, and supported through its life. And finally, no single organisation solves this alone. Better alarm management, better collaboration, and better assurance all serve one purpose: helping people make the safest decision at the moment it matters most. If this is the standard we set ourselves, then the question is not whether we have controls, it's whether those controls genuinely help people when reality starts to push back. So I'll close with this. Safety offshore is not about the perfect system. It's about resilient operations that help people recognize risk, trust what they're seeing, and make the right decisions early enough to matter. At the start, I asked everyone to think about the consequences of a collision with an offshore platform. I also asked a simple question: have we done all we can do? That question still matters because everything we have talked about today points back to it. The complexity offshore, the human factors that build quietly, the lessons that repeat, the assurance gap between what looks right and what actually works under pressure. And the reality that what good looks like is not one system, one procedure, but a whole support model around people, performance, and decision-making. So my closing thought is this: if we are serious about reducing collision risk, then we have to keep challenging ourselves, not just to install systems, not just to pass checks, but to make sure that when conditions deteriorate, when pressure rises, and when judgment matters most, the people on the front line are genuinely supported to make the safest call. And if we can say yes to that with confidence, then we're getting closer to answering the question honestly. Thanks to the Marine Safety Forum for inviting me along. We're at the side there if anyone wants to have a chat this afternoon.
Very much, Paul.
Thank you very much.
I think this is a little bit from us. Can you hear me okay? Thanks, everybody. Any questions in the room? No. Well, thank you very much, Paul. It's a good reminder of the decisions and systems we put into place onshore directly impacts what happens offshore. So that was a good reminder to all of us. Thank you very much.
Thank you.